I'm doing a bit of work on the Spider, the Alfa Spider, because I want to try and get this car on the road, MOT'd, driving, so I can either drive it or sell it. Now I've got the alarm working, all the electrics now work apart from a couple of things which I'm dealing with, windscreen wipers, one, the rev counter's another, but this is more important. At the minute I'm just looking at the engine and the timing belts, and I'm at a stage where I've just done a compression test and all the cylinders are about 160 psi, so that's pretty good. They're all the same and they're all at a fairly high level. Also, I've got the timing belt, I've got the number 1 cylinder at top dead center, but the cam locking tools won't fit on. Now that suggests to me that the cams were out of time with the crank. I thought initially perhaps it was just the variable valve thing when it was on this first cam. I thought it might be the Variator, but it's not. They're both the same, so that doesn't look good, does it? Anyway, it ran okay, kind of, but I think it'd run better if it was all perfectly in time, and these engines are quite precise about that. So anyway, I'm going to crack on and see what I find, and I'll come back to this later. Okay, I've taken the balancer shaft belt off, and this engine I've now got a top dead center cock on. I used a 90mm socket and a long breaker bar on the crank pulley nut, and you know, the equivalent of using a heavy hammer lightly, a long bar, gave you lots of control, and I've checked it and it's cock on, top dead center. Now we look at the cam locking tools, and they're both out by a similar amount, so that cam is nowhere near, these cams, neither of them are nowhere near where they should be for a top dead center position. So I suspect that was assembled wrong in the first place. Also, I noticed that you see the tensioner. I don't know if you can see it, you can't really know. Well, the tensioner has got the belt over tight, so it's not in the position it would be. Now you'd expect a belt to slacken and loosen over time, over wear, so I think somebody's been in here who didn't know what they were doing. Anyway, I had a bit of a job getting the crank pulley off, the balancer shaft pulley, and there's a bit of corrosion on it, a bit of corrosion on the inside. It was stuck, so I used this puller, which is a Nielsen one, which I bought for another task, but anyway, that worked very well and pulled it straight off without any banging of using hammers. Right, next stage then is to take off the timing belt and then get those cams into the correct position. I'm rebuilding the Variator on my Twinspark engine, and I'm just doing this quick video to explain how a lot of the websites and what have you tell you to do this wrong. Now, how this works is you've got two basic parts of the Variator. You've got this bit here, which is attached to the cam, and then this bit here, which has got the drive sprocket from the cam belt on it. And they can move in relation to each other radially because they are splined together with these helical splines inside there and outside there, and a spring pushes it in one direction and the oil pressure pushes it back in the other direction. So when there's no oil pressure, I think that's at when the engine's running at lower RPM, and oil pressure is switched in later on by the ECU through a solenoid valve, and that pushes it in the other direction, causing this to rotate about that, or vice versa. Now, when the websites tell you how to put this together, they always say when you're putting this back together, you put this separate component here, which is splined, matched up against, with the splines matched up against those splines. That is wrong. In this component is a blind 3mm hole, and in this secondary component there's 3 holes. 2 of them are 2.5 and 1 of them is 3mm. The 3mm one should line up with a 3mm hole here, and when that happens, these do not perfectly align, these splines, unless there's about a 2mm gap. Now the reason that's there is to provide anti-rattle. So one's pushing against one side of the spline and the other's pushing against the other side, and it stops it from rattling. If you took this away completely, it would still work, but it would rattle. So that's what that's there for. This component here is only there to provide anti-rattle. Now if you're watching this, it means that I've put it back together, put it on the car, and it works. So I'll see you on the next one. Trying to reassemble this with the 2 internal components that mount on this shaft, which are now slightly out of phase unless there's a 2mm gap as explained, makes it impossible to fit this in, because the splines on the shaft will ever so slightly not match up with the bottom of the 2 sliding components. So because the spring is pressing them together, and what you need is like a gap. So the way to do it is to restrain the spring, and as you can see here, I've done that using tie wraps, not right round the very bottom of the spring because that will trap it. You'll never get the tie wraps out, but you've got to be able to hold the spring back, assemble it, and then cut the tie wraps and pull them out. So I'm going to try that. There are other methods available, but this is what I'm going to try first. Okay, the tie wrap idea, or cable ties, or zip ties, or whatever you want to call it, didn't really work. It kind of worked, almost worked. I've got it together, but I just couldn't get the damn things out because they're too thick, and I broke one off inside. So anyway, what I've done here, this is balloon ribbon. Okay, it's what you tie mylar balloons with, and curling ribbon it's called. Just happened to have some kicking around, don't ask why. And I've tied the spring up to restrain it using that ribbon, and I cut it after. So let's try assembling it using that. Okay, well that worked. The curling ribbon is strong enough to hold the spring in place without slipping. You just loop it around, tie it off at the top, and then cut it carefully and withdraw the pieces, and it's thin enough and slippery enough because it's kind of like a mylar ribbon, I think, not sure, polyester of some sort, but that works. Okay, so it's about a few millimetre wide, 4 or 5 millimetre, and very very thin, and using the knife and the pliers I was able to withdraw the ribbon from through the holes without leaving any behind, so that's really good. Right, the thing to do now is put it back on the car. I've reinstalled the variator on the end of the cam, cleaned up the various components, and I've reassembled the timing belts and balancer shaft belts temporarily using the old belts and all the other old parts to test it first, to make sure that the variator problem has been solved. Now I'll start it. That's running quite sweetly now, a little bit hunting slightly, but the engine's not fully up to temperature. So the thing to do now, I'll switch this off. The thing to do now is obviously buy new belts, buy new tensioners and everything. I won't bother with the pump. To be honest, everything was in quite good order except for the main belt tensioner for the cam belt. It was a bit buggered. It was seized and wasn't tensioning correctly. I took it off, cleaned it up, freed it up, but it's still not 100%. So anyway, it was good enough for this test. So the next stage will be to rebuild, clean up all the bits and pieces, fit new belts and reassemble the timing colours. So that's pretty good. I'm quite pleased with that. I'm very pleased with that, in actual fact. And that just goes to show that the Variator assembly method shown on more than one website, but most particularly on Alpha Workshop, is incorrect. And I went to the National Alpha Day and I was talking to a guy who had a few of these Twinspark cars, and he's a physics professor, and he was saying, yeah, that's wrong. I agree with him. Anyway, there you go. So that's the end of that particular part of this repair